Good morning, mathematicians. It's Thursday, our final day of week 8, and we are starting off with Bob Floss. Bob Floss uses 6 tubs of teeth whitener on 14 patients. If he used the same amount on each patient, how much whitener did he use per patient? Our first number in our division problem is the whole thing that is being shared, right? The whole thing that's being shared is the teeth whitener, and there's 6 tubs of that. Our second number in our division sentence is how many people are sharing it or how many groups it's divided amongst. It's divided among 14 patients. So the way that we could write this is 6 divided by 14, which is the same as 6 divided by 14. Remember that a fraction is really like a teeny tiny division problem. So this really is the answer. This is the fraction of the teeth whitener that each patient is going to get. All right, let's go ahead to some true or false. Decide if each of the following is true or false. Write T for true and F for false. Here we have 16 divided by 3, but we have the opposite. We have 3 divided by 16. So this is false. Here we have 14 divided by 6, and we have 14 divided by 6. This is true. Now we have 19 divided by 2, and we see that this problem was actually taken to a number. So let's take this to a mixed number and see if we agree. Remember that the number on the top falls into the division box, and the 2 slides to the side. 2 goes into 19 how many times? Well, it goes in 9 times. 9 times 2 is 18. And how many are left over? Just 1. The bottom of the problem rises to the top, and the denominator stays the same. And here we can see 9.5. Yes, that is the answer that we arrived at as well. That is true. All right, our next problem is asking us to think about area. Remember what we've talked about, boys and girls. We've talked about how we have to stop and ask ourselves, when we look at this, take a look at what that hole was set to be. Well, our hole was set to be 2 of these shaded rectangles, right? 2 of these shaded rectangles is really what our hole was set to be. So each of those shaded rectangles represents a certain quantity. If 2 of them represents a hole, then one of them represents what? One of them represents a half. Each shaded rectangle represents 1/2. Now, how many of those do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 of those. So this is one way I could represent it in a multiplication sentence. But I know that a half of 12 is going to be 6. And yes, I know this anyways because look, those 2 give me a whole. These 2 give me my second hole, my third hole, my fourth hole. Then take a look. I could combine those 2 to be my fifth hole and these 2 to be my sixth hole. Even just by circling and grouping 2 of those together to make a hole, I'm still getting to the idea of 6 holes. So let's write a summary of this down below. Let's write that the area is 6. Now, I know that because we can see that 12 halves are shaded. And now let's use our division sentence. 12 times 1, oops, not 1/6, it's 1/2. Silly me. 12 times 1/2 equals 6. Here we go. Now we have a good explanation down below, just like it asked us to explain. Our next question is a question where we're going to decide how many of these match the situation above. Circle the expressions that represent the diagrams below. So first of all, let's analyze one diagram to see what it is, what it represents. The bottom number of a fraction is how many parts the whole is broken into. Well, the whole is broken into 5 parts. And how many of those parts do I have? How many have shading? 4 of them have shading. So I see 4/5 in this one, but I see that 2 times, right? So very clearly I can see number 1 is true because I'm seeing 2 tape diagrams and they each represent 4/5. Well, if I know that this is true, I also know that this is true because a fraction is a teeny tiny division problem. Just like I would read it as 4/5, or 4 divided by 5, I can read it as 4 divided by 5. So both of those are representing the same quantity. Now, is this not the exact same thing as number 2, except we see the commutative property? Because I can take this factor and this in parentheses, and I can switch them back and forth, right? And they're still going to represent the same thing. I still see 4/5 times 2. So 2 and 3 are the same thing, just those factors are reversed. That's the commutative property of multiplication. Now, this one, number 4, is not looking so good to me. Do I see 4 being divided in half? And do I see 5 groups of that? No. This one has the right numbers, but the wrong placement. It does not match the tape diagrams. Last but not least, let's do some solving. 4 times 1/3 is going to give me 4/3. 10 times a sixth is going to give me 10/6. 22 times 1/8 is going to give me 22. And 35 times 1/14 is going to give me, you know it, 35/14. That is it. For our week number 8, we have finished all of our problems.